Uh, okay, so good morning, everybody, and welcome to this is morning already. Oh, good afternoon, wherever you are. So whether morning or afternoon, anytime you're listening to it. So, or even if you are going to be listening to it at night. So welcome to chemistry session 4. I didn't know we're already 4 weeks into this lesson, and I hope it has really been a rewarding experience for you. I know it's a lot of money spent on data, especially looking at how network is in Nigeria. So, but don't give up on your dreams. The goal is to get at least 80 in your jam. I don't think I got 80 in my own jam during my own days. So, but I've taught students who have gotten 90 plus. So, chemistry is kind of weird. I don't know. I've never gotten somebody that got 100. So, but I know I've gotten 90 plus, and so I'm sure you too can get more than 90. Please, when does this lesson class end? Is it like end for today or end forever? So depending on when your jam class is, maybe I will if it is in terms of this 29th, I guess, the last day of jam. Okay, so it's supposed to be last day of jam. So but if I have people that are writing WAEC and they want maybe me to do WAEC practical before with them, I will do that. And also, if you are writing WAEC and then you want me to extend it and then revise prior to WAEC for you, I'll also do that. So I think I have the time. Yeah, so nothing will stop me. So, but it's all about request. Okay, so let's just begin. It's a long day. Okay, so today we are looking at oxidation and reduction. I'm going to make it in the simplest format you have ever seen. So this is what this class is all about. Oh, when the class will end, it's my first time. It's usually a 1 hour class. So this is I started at 6:07. Oh, 12:07. So if your own time is 12:07 there, we are starting now. So just add 1 hour to it. That'll be like when you'll be ending. Or if we have maybe we have to finish maybe 5 minutes later or 10 minutes later. So that's not too bad. So it's supposed to be like a 1 hour class. So okay, so this is oxidation and reduction. So both of them combined together redox. So the person that coined it maybe decided to put uh, oxidation first, reduction first. Sir, can you revise what you have taught for those of us writing JAM? So if you're writing JAM, I'm going to do you a favor. Maybe on the WhatsApp group, I want to do a JAM revision day. So JAM starts like 19th, I guess. So maybe like anytime on Monday, Tuesday, Wednesday, in the morning, maybe like in the afternoon, maybe around 3:30, yeah, 3:30 p.m. or 4 p.m. I'll just dedicate 1 hour to just revise past questions. I think I can actually sacrifice that. So we'll look at people's response on WhatsApp poll, and then I'll pick a day and just do all day revision, not all day, just revision of all the possible questions in JAM and how to tackle those questions. Okay, so let's not waste time. Normally, I would have revised, put this on a slide. So just for you to study on your own. So in chemistry, we have oxidation and then we have reduction. So redox is oxidation and reduction. So when we talk about oxidation and reduction, there are different ways we can approach that concept. So there are different ways we can define it. So I will just go straight to, I know you already have these notes, which makes a lot of sense, which makes it easy for us. So is a reaction in which some oxygen is added. So I want to, for those of us who are doing white, or so for the first, or yeah, hearing me for the first time, I'm not the kind of child that will tell you that oxidation is a process. Is it a system? You can say oxidation is not the I don't have to say. Some people say oxidation is the addition of oxygen. Yeah, that's That's some textbook doing it that way for you. But I don't think I'm in that kind of category of people saying oxidation. It's just a process where oxygen is added. So if you look at this equation, you look at this is a methane. There was no oxygen here. But let's take a simple look at that. See, here, there's oxygen added. And here too, there's oxygen added. You can see here. So we have added oxygen to both of them. So we can just say that oxidation have taken place on both of the main reactants. So that's kind of difficult to really, really look at. But here, you can just say this is an oxidation reaction because we're adding oxygen. If you look at this ion here, the ion here is a simple case. Ion, we just added oxygen to it. So it is now ion coupled with oxygen. So that's an oxidation reaction. So this is just to define it in terms of oxygen transfer. So there are other ways you can define oxidation reaction. So look at this one here now. Okay, this is another proper example. Okay, you can define it in two ways. To carbon, we have added oxygen, that's oxidation. To ion, we have removed oxygen, that's reduction. So removal of oxygen, removal of hydrogen, or removal of oxygen is reduction. Addition of oxygen is oxidation. So you can see two cases here now. Now, take note of what I'm going to be saying, the way I'm going to be saying it, so that you don't get confused. Because I remember doing my own time too. I think I was particularly confused when I didn't know the difference between oxidizing agent and reducing agent. So sometimes it can be very, very frustrating for you. So for those of us uh, who I just wanted, okay, let me. Okay, somebody was asking for the group link, so I'll just post it on the chat session so you can join the WhatsApp group. So that's the best I can do for now. So during my own times when I was in secondary school too, I had that same issue where I wasn't sure of what I'm going to be talking about it. Now I'm talking about oxidizing agent and reducing agent. So oxidizing agent is that substance that brought about that oxidation. So use that word. Look at it. What brought about oxidation is oxidizing agent. What brought about reduction is reducing agent. So now let's say, for example, or if I say oxidation is the addition of oxygen, who did we add the oxygen to? Carbon here. Okay. So carbon is the person that we added the oxygen to. But who brought the oxygen is Fe2O3. Fe2O3. So this guy on the left hand side. So that person becomes our oxidizing agent. Okay. That's very simple. Okay. So who is our reduction is the removal of oxygen. Who did they remove the oxygen from Fe2O3? Who caused this reduction to take place? Is ordinary carbon, C. So ordinary C is our reducing agent. So you hear me mentioning oxidizing agent, reducing agent, oxidizing agent, reducing agent. This is exactly how it happens. Okay, so if you say it's oxidizing agent, take note of what it's doing. Oxidizing agent is something that brought about that oxidation. Reducing agent is something that brought about that reduction. If there was no oxidizing agent there, they wouldn't have caused any oxidation. Okay, so very easy. Okay, so another way to remember this thing is the easiest way to always remember. Like this is, I don't know this is the easiest way, and that's the one that is most common. So if you are confused about oxygen and hydrogen or electronegative element, electron is the easiest way. So oxidation is the removal of, I don't like that definition. I don't like saying it's a removal. Oxidation is a process where electron is removed. Yeah, it's a process. So reduction is a process where electron is added. So look at this X here is transferring electron to Y. So remember in high school, maybe in secondary school, there's something I wanted to say. So yeah, I remember. Remember at the beginning of your chemistry. So we have sodium changed, we lose an electron becomes sodium plus. So I'm saying it will lose an electron because whenever an electron is lost, you put the electron on the right hand side. So look at what happened there. Sodium loses an electron because sodium plus. So that simply means that whenever a substance loses an electron, it will become positively charged. In fact, not only will it become positively charged, look at how we can easily remember it. The oxidation state of sodium here is 0 because it's not carrying any charge. But the oxidation state of sodium on this right hand here is plus. That's plus 1. So there's an increase. 0 to 1, that means there's an increase. Minus 2 to 0. Is that an increase or a decrease? I want you to be thinking about it. Minus 1 to 0. Minus 1 to minus 2. So let me know. So which one is going to be an increase here? You can express that in terms of you are owing some minus can mean you are owing, plus can mean you are rich. Okay, so let's use that word. If you are owing -1 before, and now you are gone to -2, that means you are owing twice. So that means you are reducing. You are not rich, you are reducing. So if you look at the oxidation number, if you look at the test of oxidation number, if it is -1 before and now is -2, that means it is reducing. So that is reduction. Whenever is reducing, see the word, it's very simple. Reducing is reduction, increasing, oxidation. Very simple. So if you can remember this, whenever the oxidation number is reducing, that means it's reduction. Whenever it's increasing, that is oxidation. So this is oxidation is -1, you're owing before. Now you're no longer owing, that means you have increased. So that's oxidation, this is reduction. Okay, so very, very easy to remember. Okay, so no big deal. Okay, so if there is an increase, that's oxidation. If there's a decrease, that's reduction. So gain, so reduction can be somebody gaining 1 or 2 electrons, and oxidation, yeah, -2 to 0 is increasing. Thank you very much. So um gain of electron. What do I mean by gain of electron? Somebody is collecting more, is becoming more in terms of electron, is becoming more rich in chemistry. But in terms of maybe money, yeah, he's becoming very broke. Let's just use that word to compare. So if you have to remember it in a different kind of way. Okay, so no big deal to talk about. So the question I want to talk about, so the person that is giving out that electron, the person that is giving out that electron, the person that is gaining that electron. So if I'm gaining, my oxidation number is reducing, right? So that means that I am being oxidized. I have been given electron. I have been oxidized. So when I collect the electron, just tell me, say, I have, if I'm losing electron, so I remember I'm a reducing agent. So reducing agent will be the one that will be losing the electron. So when it reduces, when it loses the electron, it becomes oxidized. Okay. When an oxidizing agent, the one that is gaining the electron, oxidizing agents are the one that will gain the electron. When they gain the electron, they become reduced. Reduced in terms of their oxidation state. Remember what I'm talking about? In terms of their oxidation state. Remember that we are saying that the oxidation number will be reducing and reducing. So when somebody gains an electron, it becomes reduced. You see? Very simple. So look at that concept in that way that when you say it's reduced, I talk about the oxidation state. Okay? Very, very important. I hope you remember that. When it becomes oxidized, think about, I like using the word, I drank water. Oh, I've been oxidized in oxygen. You drank water. You ate food. If it is water, I say, oh, I've been hydrated. You see, if I lose an electron, you say, oh no, I have been really oxidized because I'm happy. Well, are they happy to lose an electron? Yeah, sometimes most of those elements, whenever they lose an electron, they are really happy because they attain octets. So that's why you should be happy that they lose an electron. So that kind of makes them more stable. Okay, so let's see how I don't think I need to. If at any point I am too fast or you're not understanding what I'm saying, just drop the question on the chat session and I will quickly answer it. One hand, no stress. So look at here, sodium here doesn't have any charge. Chlorine on the left-hand side here doesn't also have any charge. So no charge, no charge. So whenever any substance doesn't have any charge, just know that it is zero. That's very simple. But now chlorine is having a positive charge, so +1. So that means the change is 0 to +1. Okay? Chlorine here goes to 0 to -1 because the charge chlorine is having here is minus. See, the charge 0 to -1, not 0 to -2. You know, some people are very, very smart. So yeah, I understand that people can be really, really very smart mathematically, but in chemistry wise, they don't understand what we're talking about. So it goes from, so it's the charge we're having on top that we are talking about there, from 0 to -1, 0 to +1. So if I'm saying 0 to +1, that's an increase. That's oxidation. Very simple. So that means sodium is undergoing oxidation, is increasing. Chlorine is undergoing reduction, is reducing, or it has been reduced. Let me use that word. It has been reduced, not is reducing, it has been reduced. Okay, so that is very, very simple. Okay, this is the exam condition. I don't need to be making it more complex like that. Just understand what the exam question will be asking for you. Okay, so I don't usually ask students to memorize yoga. Who cares? You can, if your teacher have showed you this thing before, yeah, it's fine. Loss of electron is oxidation, gain of electron is reduction. Yeah, whatever they like. Yeah, there are different ways you can remember it. Oil rig. So if you can remember oil rig, it's also another way to remember. You know that oil rig where they used to like get oil from underground. Yeah, the cars. That's an oil rig. So that's easy. Okay, so whenever yeah, so just a summary here that this is different ways we can summarize it. Like all these definitions are put together. You can just screenshot, like play around it. Um, Whenever that you are talking about oxidation, you can compare oxidation to reduction just simply by using this. So when you talk about oxidizing agent, that is where the students usually have this complex confusion all about who is my oxidizing agent, who is my reducing agent, and that is where WAEC and JAM questions usually come from. So JAM questions are usually what is the change in oxidation number? That means is it plus from 0 to 1, minus 0, -1 to 2, all those kind of numbers I just showed you earlier. That is what comes out in JAM. And then another way that JAM asks the question is which of the following is the oxidizing agent? Is it this reactant? Is it this product? Whichever one, they just A, B, C, D. So I'll just show you how to uh, answer those questions. Then if it is Y could tell you, show that oxidation and show each of the following, is these reactions oxidizing or reducing? How would you know? Show it. So that's the next I'm going to be explaining to you. Yeah, I don't want to be suffering you too much. There's no, I think I've already mentioned this sometimes too much. Yeah, this is like how you determine the oxidation state because that's the easiest way to remember oxidation and reduction, loss of electron and gain of electron. Okay, so very simple. So I've already shown you here that when an element is not carrying any charge, the oxidation number is 0. I don't want to be stressed. Okay, yeah, I did another wire question that since I can always play with in jam. Okay, so the basic rule here is that see this, this is this whole compound here, I've just echoed it. That -2 on top of that oxygen is for everybody. It's not just for only oxygen. It's for everybody. So remember when we talk about periodic table here, and I told you that when you get into your into the exam hall, this is chemistry. Sketch that your first 20 elements. Sketch it. If you, let me show you what that is. For those of you who just joined the lesson, see what I told them. See what I sketch it. See, I can sketch my own first 20 elements. So I know that I have 8 groups, so everybody knows that. So you have, this is number 1 and this is number 2. So you can always sketch this in. So I have 8 groups. 1, 2, 3, 4. 2, 3, 4, 5, 6, 7. Okay, so let me show you what I usually do. Very simple. Very, very simple. That by sketching a periodic table is this easiest, is the best that can ever happen to you. So look at what I'm going to do. This one is group zero, so all of them have zero oxidation states. So I'm going to start from here. See what I'm going to do. We are going to get to equilibrium. Plus one, plus two, plus three. Okay. 0, minus 1, minus 2, minus 3. See what I just did? So we have gotten to a middle ground there. See, middle ground. So the middle ground here is this carbon, guys. So you can start from minus 1, minus 2, minus 3, plus 1, plus 2, plus 3. So see what I hope you got what I did here. So uh, plus 3. So we have plus 1, plus 2, plus 3, minus 1, minus 2, minus 3. So we want to put 0 for that noble gases. So every other person here, so this is my transition element. So transition element. So that's the question that they are going to. So if you can do this thing for yourself, you are on your own all the way to answering all your questions. So some elements can have more than one oxidation state. Yes. So on a recess, if they give you what is, let's say in this kind of question now, what is the oxidation state of potassium here? I know you can easily figure that potassium is number 19. Potassium is somewhere here, plus 1 in group 1. So that means potassium is going to be plus 1. You're asking for magnesium. Magnesium is number 12. So that means it's in group 2. It's around here. So plus 2. So you can remember this is, don't memorize it. Memorizing doesn't help you. What is the oxidation state of chlorine? Oh, it's in group 7, minus 1. Fluorine, minus 1. Bromine, minus 1. As long as they're in the same group, they have the same oxidation state. What is the oxidation state of oxygen? Minus 2. Sulfur, minus 2. They are in the same group. Nitrogen, minus 3. So sometimes an element can have more than one oxidation state, no problem. But the one that is stable is the one I've shown you here. So ordinary sulfur, you give ordinary sulfur minus 2 because it is with this oxygen group here. That's one that is very stable. Okay, remember. So if the element can have more than one oxidation state, like sulfur 4, sulfur 6, sulfur 8, yes, no problem. They can now tell us to calculate it, no big deal. But the primary thing is for you to know that with this periodic table like this, you can easily remember, the oxidation state of many elements without cramming. Hydrogen is usually put in plus in the group 1. So that means hydrogen is plus 1. That's why we usually write H plus. H plus. That's why we usually write O2 minus. Why is it minus? Those ones are the ones that are going to gain. So be smart, be smart, be smart, be smart. Non-metals will always gain. So it's easy for you to know it's going to be a non-metal. See, connecting periodic table to this, you know that it's negative. It's going to, if it's negative, that means it has gained. That means it's an oxidizing agent. Any substance that will be gaining electron is always an oxidizing agent. Very simple. So now chlorine is going to be an oxidizing agent. Fluorine oxidizing agent. Chlorine oxidizing agent. Nitrogen, mostly oxidizing agent. Oxygen, oxidizing agent. You see, that's one way. So if you say a chemical equation, they say which of the following is the oxidizing agent, you don't even need to be calculating the oxidation number. Just remember this in your periodic table. It's going to gain. That means it's the oxidizing agent. Very, very simple. Now, let me just go back to this calculation on the screen. So now, of course, so if an element is having more than one oxidation state, that's one that they always tell you to what is the oxidation state of the element, what is the oxidation state of the element, because it's going to have more than one oxidation state. Like chlorine here now, we already know that chlorine is going to be -1, AB, but now it's in the middle of this, is in K, is between K, O, and C. Now we already know that chlorine is having an oxidation state of -1. So the moment they tell you that, what is the oxidation state of chlorine in this compound? Obviously, that's the base tells you that means that chlorine most likely have more than one oxidation state, which is very true. Okay, so now as long as this whole compound is not charged, that means the total oxidation state is equal to 0, just like KClO3 is equal to 0. Since they did not ask us about oxygen, they did not ask us about potassium. That means we use the normal oxidation states that we saw in that periodic table. Potassium is in group 1, so +1. Since they're asking us to find the one of chlorine, let's put Cl. Oxygen is in group 6, that's -2. But we have 3 oxygen here. You have 3 times -2. Everything is equal to 0 because the compound did not have any charge. So +1, so +1 plus Cl minus 6 is equal to 0. So Cl minus 5 is equal to 0. That means Cl is equal to +5. Now let me give you one big secret. If you are in WAEC, you write Cl is equal to 5, you are wrong. This one is wrong. You cannot say Cl is equal to 5 because you are not doing monetary chemistry. It's not money we are writing. It's chemistry we are doing. So +5 shows that it's positively charged, not just ordinary 5. If you write ordinary 5, I will not mark it for you in WAEC. So that is the rule. You must show that it's an oxidation number. You must put the positive charge there. So here, you can see a chlorine here is +5. Okay, so that's no big deal, no big deal, no big deal, no big deal. That's easy. Hope you got the rule. Look at this compound, MnO4. They are asking us to calculate the oxidations of Mn in the compound. Obviously, that means it is having multiple oxidation states. Any element that they are telling you to calculate, that means the original oxidation state in the periodic table does not count. It is the one that is in this compound that counts. So that's a Mn04 is equal to -1 because the whole compound is having a -1 charge. That -1 does not belong to us, it belongs to everybody. So that's why I'm equating it to be equal to -1. So if you are calculating, so that means oxygen is -2, the way it is in the periodic table, we have already used it. Mn plus, how many oxygen do you have? 4 times -2 is equal to -1. So Mn is equal to +7. So very simple for you to remember this thing. This is one of the easiest questions that you may likely see in your JAMB question. And within 5 seconds, clear it and run away, move to the next question. If it is in WAEC, just show your working. So this is just a slide for you to see. Oh, this is the oxidation state or some most common oxidation state for some elements. Okay, so no big deal. All right. So if they say ion 2, ion 3, that means that the oxidation state is +2, +3. Copper 1, copper 2. Copper 1 means that it's having oxidation state of +1. Copper 2 means that it's having oxidation state of +2. So every other one is just general stuff. And these are like the common radicals that you can always see how you split compound. So this is just for you to know how you will split them. So that's like, how do you, what do you, Mr. Nkwocha, what do you mean by splitting? Look at this, H3PO4. That means if I'm splitting it, I'm going to split it between the radical. Do I have any PO4 on my slide? Boom, yes, look at it here. So that means this compound is going to split to hydrogen is usually +1. Phosphate is going to be PO4 3 minus. Okay, so because I have 3 hydrogen there, I just have to put it as an initial. No big deal. That's exactly what we are saying. Then when we are doing electrolysis, we are saying electrolysis is ionize. The compound will ionize, and this is how I usually ionize. You don't have to memorize. With this slide alone, you can see how compounds ionize. Let me give you another one. ZnCO3, zinc carbonate. Okay, zinc. In the previous slide, I've already shown you that zinc is +2. So let me just go back to that. Is that zinc here? Yes, zinc is +2. Yeah, look at it on my right hand side. Yeah, look at zinc. Okay, hope you can see it. So let's go to the next slide. Zinc carbonate. So when you are doing electrolysis, no cramming. Do I have carbonate on my screen? CO3. Yes, it's at the bottom. Number 12. Check it out. Number 12. So if I'm splitting this compound here, I'm going to speak as Zn2 plus and carbonate CO3 2 minus. See, that's how it works. That's how when we are doing electrolysis, I tell you that I should break down this compound. This is how you learn to break it down using these 2 slides. Okay. No too much dragging on this. Let's move on. Those of you that are waiting for, if you want to do more practice online, don't waste your time. Just go to this website and you can see more. No big deal. Why question? Jam question. What is oxidation? What is the oxidized? What is oxidized and what is reduced? See here. Very simple. You don't need to suffer too much before you understand this thing. What is oxidized? What is reduced? See the answer to this question. You are in jam question, you are inside jam hall. Look at what is oxidized and what is reduced. Don't force yourself to be wasting time answering question. The moment you see what is oxidized, the other one should be what is reduced. So automatically, this is out, this is out. Or whatever that is oxidized or whatever that is reduced, whatever is the oxidizing agent, whatever is the reducing agent, they are usually the reactants. So don't focus your attention on the product. So the moment you say, what is the oxidizing agent, what is the reducing agent, go to option A, B, C, D, automatically cancel out any of the product, any of the ones that are on the right hand side, cancel it, that they are not they're never going to be the answer. And then the next thing you need to do is to check out the one on the left hand side. Which one is alone? Very simple. That's the fastest to do. Which one is alone? Br2 is the element that is alone. That means the oxidation state there is 0. So that means it's going from here to here. That means Br is 0 here. Now let us calculate the oxidation of Br, which is the element on the right hand side. So you have AlBr3. I don't care about the two, but let me put is equal to 0. Let me, because of those of us that do not know maths. So let's do it this way. 2AlBr3 is equal to 0. For if you're a mathematician, just divide it by 2, by 2 to eliminate these two. 0 divided by 2 is 0. So you just go ahead and say AlBr2 is equal to Br3 rather is equal to 0. Then now go to that your sketch periodic table. Aluminum is in group 3. It's under +3. That means this aluminum is going to be +3. So +3 +3. Oh, come on. +3 plus 3Br. We have 3 of those Br that we don't know is equal to 0. So we carry this +3 to the side because -3. So Br is equal to -3/3, which is equal to -1. So automatically, 0 to -1, did it increase or did it reduce? Reduced. Automatically reduced. So that means Br is reduced. And remember, oxidizing agents are reduced. You have answered that question right there. 20 seconds. 20 seconds. You cannot be wasting time doing this kind of thing in 20 seconds. So Br is what? Is reduced. Automatically is an oxidizing agent. In fact, remember what I told you before, that if it's a non-metal, it's a reducing agent. If it's a non-metal, if it's a non-metal, it's an oxidizing agent. If it's a metal, it's a reducing agent. That's another way to remember it. But now we're having two non-metals. One is bromine, and the other one is iodine. So go back to that periodic table. Which one is on top? Bromine is obviously on top of iodine in the periodic table. So that means bromine is a stronger oxidizing agent. So it can never be iodine or iodine. So please take note of that too. It's very, very important. Okay, so if you are lost, just call my attention on the chat and I'll be able to answer your question without hesitating. Okay. So it's very simple. The moment you know that, oh, Br is reduced, automatically the whole of the compound. I've seen sometimes jam will not put AlI3. AlI3. Which one will you pick? Will you guys be picking I3? No. You have to pick the whole of the compound. AlI3, all of them together, both of them together. Okay? Very, very important. Don't forget that. Don't separate it. Okay, don't say it's the only reason why I'm picking Br2 because it's just all alone. But whenever a compound is together, pick the whole compound like that. Don't ever split it. All right, so that is how the cookie crumbles. Okay, let's move on. Is there another one? Let's see. Okay, so I think I've already the slides already ended. Look at this one. Very simple. What is oxidized and what is reduced? What is the change in oxidation number? What is the change in oxidizing reduction number? Oxidation number, not a reduction number. What is the change in the oxidation number of whatever species is oxidized or whatever species is reduced? Remember, this is okay. I have these are questions. Automatically out. None of those ones I cancelled is our answer. Very simple. Look at this one, it's easy. Potassium is a metal, reducing agent, sharp. Bromine is a non-metal, oxidizing agent. Easy stuff. Easy stuff. Don't memorize. Magnesium here, bam, is on its own and is a metal. Automatically, that is our reducing agent. Simple. Don't cram it. Did you see what I just did here? Automatically, because it is alone, automatically, that's our reducing agent. Copper here is a metal, alone reducing agent. You don't even force yourself to memorize anything. The moment the element is alone like this, is our reducing agent. What's our oxidizing agent? The whole of this one, CuSO4 is our oxidizing agent. Br2 is our oxidizing agent. AgNO3 is our oxidizing agent. Simple. Don't memorize anything. See, did you see that I don't need to go and be checking oxidation number or reduction number? What's wrong with you? I talk about reduction number. I don't need to be checking oxidation number. It's very simple. Can you see? So no cramming. You are good to go. So if the question I say what is now the change in oxidation number, that is when you now calculate. Okay, automatically magnesium is 0. So you need to calculate the oxidation state of magnesium here on the right hand side. Of course, that is where that slide I gave you make your life easy. So let me use MgSO4 is equal to 0. I'm going to treat SO4 as a polyatomic radical. So all of them are together. Yeah, all of them are together. So I can decide to group these guys together like this. Remember, we usually do SO4 2 minus because you're in the exam, you don't have time to be wasting. So you just do Mg minus 2 is equal to 0. So Mg is equal to plus 2. Sharp, sharp. If you choose to split it, you get into trouble. Why did I say you get into trouble? Because you say, Mr. Nkwocha, sulfur is what? Sulfur is group 6 minus 2. Voila, you don't be that. You have gotten it all wrong. Why would I say there is a lot of wahala in splitting it? That simply means that your answer will be very, very wrong. Because if I say sulfur, is minus 2 in this case, that means I'm not treating it as a polyatomic molecule or radical. So that means I'm doing Mg, I'm writing at the bottom of the screen, plus minus 2 for sulfur, um, plus 4 times minus 2 for oxygen. Everything here is going to give me minus 10. Abi? Yeah. So magnesium is going to give you totally plus 10. See? Because you did not respect that it's a polyatomic radical. It's polyatomic. The radicals are together. NO3 is together. SO4 is together. You see? How do I now? So how can I? There's a way I can actually split it by using, because how do I know? Because it said magnesium. Okay, this is MgSO4. That SO4 is tetraoxosulfate 6, sulfate 6, sulfate 6, meaning that the oxidation state of sulfur in that compound is 6, not 2. So that means you have to remember the name. You see, that's where the problem comes in. And you don't have time to be writing the name of the compound first. Ask yourself, am I sure that this name is correct? Before you now start answering the question, please, oh, brothers and sisters, these are polyatomic radicals. You must treat them in group, not individually, because you're writing an exam. Since I'm shouting, but it's interesting anyway. So some people have some questions. But in the second equation, potassium is also alone. Yes. If once the element is alone that way, automatically you treat it as a single person. But potassium is a metal and bromine is a non-metal. Okay, so you guys, I guess, thank you very much for helping answer that question. God bless you guys for responding to the question. All right, so super easy, super easy. Thank you for that. Means you guys understand what I'm saying. Okay, so let's move on. All right, so yeah, this is the explanation. I think it's also in the notes. They said not all reactions are redox reaction. This is where I could be begging to catch people. So how do I know if a reaction is redox? Very simple. Is it a synthesis reaction? Is it a decomposition reaction? The moment is splitting and one of the elements is alone, automatically is redox. The shortcut, picking the right answer, which of the following is a redox reaction? They'll give you 4 equations and you have to pick only one answer. In 5 seconds, I'm going to show you what. If it is synthesis, synthesis means that you are combining two elements to form one compound. Is a redox reaction. If it is decomposition, that means a compound is splitting into two substances, and one of them is an element, is redox reaction. Simple. I don't need to be explained to you. The slide will explain to you. You already have it in your own background. So you can use the oxidation state to confirm. Why, Mr. Nkwocha, why don't you explain it? If that is what you're thinking, of course, the slide is explaining it to you already. So because the oxidation state of hydrogen here is 0, but on the right-hand side, it has turned to +1, there has been an increase. So whenever there's an increase in one of the oxidation states of the one of the elements, automatically is redox. Chicken, no wasting of time. Combustion reactions. Yes. Combustion reactions are also redox reactions. And single displacement or replacement reaction are also redox reaction. The moment you see that one of the elements is alone on the left-hand side or on the right-hand side, automatically is redox. See, this one is alone. This one is alone. Automatically, that's a redox reaction. You see what I told you? Very, very simple. The moment one of the elements is alone, is redox reaction. You don't even need to be checking. You have 20 seconds. Use the remaining time under your jam day to go and solve your physics and mathematics question. Look at this one. Is this a double? See, is there any single element here? No, then it is not a redox reaction. Boom. Very simple. Then it is not a redox reaction. See, that's double replacement. So why are they here? Okay, how do I prove that it's not a redox reaction? The oxidation state of each element on the left-hand side is the same thing as the oxidation state of each element on the right-hand side. Automatically, let's see if it is true. Silver is +1 here, silver is +1. Chlorine is -1 here, chlorine is -1 here. Lithium is +1 here, lithium is +1 here. Nitrate is nitrate. So nitrogen here, 5, nitrogen here, 5. Oxygen here, -2, oxygen -2. Automatically, you see, everybody cancel out. The moment everybody cancels out, there is no change in the oxidation state of anybody. It is not a redox reaction. Easy peasy, right? Yes, that's why you're here. Data money well spent. I'm just I love to smile. Okay, so that is for jump people. Maybe for white people, that's why you now start saying half reactions and half reactions. Yes, I've already shown you how to identify changes in oxidation and oxidation states. The moment you identify the changes in oxidation state, you are good to go. Now you already see this one. Now this is a redox reaction because sodium is alone, fluorine is alone. You already know. So the question is, how did it change? Let's see. Sodium is 0 here. Here is now +1. So sodium goes from 0 to +1. That means it's increase. Increase is oxidation. Put the how many? What is the difference? Is it 1 or 2? What is the difference between the one on the left-hand side and the one on the right-hand side? If it is 1, put +1e. If it is 2, put +2e on the right-hand side. Simple. I think I like this one. Let me show you this one. Magnesium plus oxygen will give me magnesium oxide. Very simple. Magnesium is 0 here. This is a redox reaction. It's a combination reaction, right? Obviously, magnesium is 0 here. That means, so let's calculate the oxidation state of magnesium here. So MgO is equal to 0. We always know that oxygen is in group 6, so it's -2. So Mg -2 is equal to 0. So Mg is equal to +2. So automatically, it has gone from 0 to +2. How do I write the half equation for this? That's right. Mg has changed to Mg2+. Is that an increase? Yes. Put the 2 electron on the right-hand side. Why should I put 2? Because that is the difference. The difference between the one on the left-hand side and the one on the right-hand side is what you put. That was so easy, right? Boom. Don't mind me. That's kind of interesting chemistry this morning. Imagine waking up, okay, like somebody just waking up this morning and waking up to something beautiful as chemistry like this. Come on, guys. You wouldn't want to have a bad day. Come on. You will never have a bad day. But it's okay. Let's move. So let's see what happens to oxygen. Oxygen here, oh, where's my equation? Mg plus O2 will give me MgO. So oxygen here is 0 because it is on its own. Whenever an element is on its own, automatically is 0. So 0, you need to calculate the oxidation state of oxygen on the right-hand side there. Since you already know that magnesium is +2, so you can do that. MgO is equal to 0. Now we know magnesium is +2. +2 plus oxygen X is equal to 0. X is equal to -2. So oxygen goes from 0 to -2. So oxygen here, oxygen 2 minus. If you see, I put the oxidation number on top, not at the back. So what happened here? It has decreased, reduced, reduced. That means that it has gained electron. Who gained the electron? The reactant. So put the electron on the left-hand side there. Plus, how many electrons? 2. Very simple. Yeah. Or that is one of the easiest way to run the streets. Okay. Somebody say, but there are more difficult questions. Come on. It's the same concept. Let me not talk it too much. Oh, horse tail. So there's a tailing of electron. Who cares about this? It's for you to learn. That's not my business. Okay, so have reactions like this. This is why I don't want to be wasting time with doing why something, because we can easily, okay, I can just show it to you. So let's see, this is exactly what I'm showing. So zinc is alone here, so it's 0. Calculate this here, +2. See, zinc goes from 0 to +2. That means reduce. Chlorine, look at what happened to chlorine. Chlorine is -1 here, and chlorine is -1. Oops. Automatically, that guy did not participate in anything. He was just spectating. He didn't throw the ball when the ball went out of the field. He didn't cheer his whole fan. He didn't cheer the away fan. He was just there watching. Maybe he's a neutral fan. So he's just spectating. So he's a spectator ion. They do not experience any change in the oxidation number. So they are just spectating. So that means whenever you are writing your half reactions or half equations, never put the spectator ions. Only put those that are actually doing the chemistry. So copper is +2 here. You see, +2. It has changed to 0. What is the difference? +2. So that means it has gained. +2 to 0, reduced. Brothers and sisters, so easy. You can never beat this kind of simple chemistry that Mr. Nkwocha is on fire today. Okay, that is how easy it is. So you can write the half equations. Once you are written the half equation like this, you are set to go. If it is in WAEC, you now check. If so, the number of electron loss is 2. Number of electron gain is 2. Beep. Automatically, that is a balanced redox equation. If you now want to write the combined redox equation, this cancels this. So all the reactants together, all the products together. Do I need to write it? Yeah, let me just write Zn plus Cu2 plus will give you Zn2 plus Cu. So that's we have made a redox couple. Yeah. A redox couple. So if you are doing electrochemistry now, so you understand that, like electrochemical, so that's what I'm talking about. So this one too is also electrochemistry. Okay, so I don't want to be wasting too much time. The complex ones that you can even see, treat them as treat those polyatomic radicals as one. That's the secret here. So how do I treat this as one? See, SO4 is 2 minus. SO4 is 2 minus. So nobody cares. SO4 is 2 minus. So that means it is spectating. It's the same charge is having on the left-hand side, is the same charge it has on the right-hand side. Automatically, it is spectating. And you don't put them in the half equations. You see, that's why I didn't even bring it down. Let's see. Potassium here is +1, is a group 1 element. Potassium is +1, is a group 1 element. It is spectating. Do you see it in the half equation? No. Iodine here is -1, but iodine here is alone. That means it's 0. You can see that's why I brought it down here. Can you see? Iron here is +3. Did I say iron here is plus what? Okay, yeah, that's +3 because of these 3 here. Yeah, it's +3. But iron here is +2. Of course, you can calculate it. I've already shown you how to calculate it. Say +3 to 2. See, that is so easy. You don't need to fear at all. So what you simply do, you need to practice and God will obviously answer your prayer. If you have confusions, then you can send me WhatsApp message on the group. Just drop the message on the group chat and I will respond. I'm not a bad person. I'm always ready to help students. That's why we're having this class now. Okay, let's move on. So I had that balance, oxidation and reduction equation. I just showed you how to do that. You can even start with this simplest of copper here. Let me even play around with this one. This before I run away. Copper, see? That means copper 0 here has changed to copper 2 plus. You see? What is the difference? 2. That means there is an increase. Put the electron on the right hand side, increase by 2. Silver here is +1. So I have Ag plus has changed to ordinary Ag. So that means +1 to 0. What is the difference? +1 to 0 is decreasing. That means it's gaining. The difference is 1. Very simple. Now, the number of electron loss is 2. The number of electron gain is 1. Does it make any sense? No. That means the reaction will not work. So we need to make sure that the number of electron loss is equal to the number of electron gain. So how do we do? How do I change this to here? This one here to 2 without offending the Gauss? Then that means I will just have to multiply everybody here by 2. So multiply everything by 2. That I have 2 here, 2 here, and 2 here. You see? Automatically, you have done the best thing ever. And you have not offended anybody. So now the number of electron loss is 2, number of electron gain is 2. That simply means that you are on your way to balancing the redox equation. Since it is equal, so you can cancel out the electrons. And then write the reactants together and write the products together. We are back to where we started from. See, that is very, very easy peasy. I'm sure you can do the first equation by yourself. People always say the second one is the hardest. So I use that mindset to do the second one. So before you can kill me, I say, this man. Okay, so that's actually very true. Okay, this one is 0, and this is -1. That means there's a decrease. See, that's easy. This is -2, and now is 0. That's an increase. So no big deal, right? That is our oxidation and reduction that was traumatizing people. Oh my God. So easy. Really? Oh my God. That this is the easy one. Why don't you do the difficult one? Why don't you put oxygen and hydrogen and blah, 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 blah? Come on. Don't be too wicked to yourself. I'm not showing you these rules, but you can read it on your own. But we only go ahead and apply it and see how this thing can really, really help us. Okay. Let's see. Does this one make any sense? Yeah, somehow. So let's see what is happening here. Easy peasy. Now, let's go back to the half equation. Let me do it again. +2, 0, 0. Oh, what I say +2 -2. Oxygen is usually -2, right? Yeah. And this is 0. Hydrogen is +1. And oxygen is -2. So oxygen obviously is spectating. It don't change. So this guy goes away. We don't care. So copper 2 changes to ordinary copper. See? Half equation. Then hydrogen changes to. Last one's easy. Yeah. No big deal. These two is just to make sure that the number of electron loss is equal to the number of electron gain. Okay, so that's we always have to put hydrogen 2 here. Okay, so that's very, very important before you go and confuse yourself. But so how come we don't put this 2 at the back here? Here, this hydrogen here is a molecule. So you do not change the subscript, that two. And then how do I do that now? Now it's 0 here, it's +1 here. But now we are now having 2 hydrogen atoms. So each of them has +1. So that's why we decided to do 2 hydrogen here now. So it becomes 2 times +1. That means +2. That's why we are putting it there. So we didn't have to multiply throughout. Okay. So I'm going to post this video. So in case you want to rewatch this class and see how this is another easy example for you to play around it. Yeah, this is the one that you guys usually see in there. Your teacher usually used to confuse you in the example. And they're like, oh my God, what is happening here? Damn. But I'm just going to explain And I'm sure the explanation is already on the side, but I don't care. But let me just show you. In 2 minutes, let's see what we are going to do. 2 minutes, see, ion goes here. So this is ion 2, this is ion 3. So automatically that solves all your problem. So you come here and say Fe changes to Fe 3 plus, and this is 2 plus. And then manganese here changes to this. You see? Now, the question here is, the question here, remember that this reaction is already in the ionic state. So you cannot remove this oxygen from this manganese ion. Remember, because it is the whole molecule that is our oxidizing agent. So you have to write the whole of them like this. MnO4 minus has changed to Mn2 plus. That is the reason. So that's why we have to bring in hydrogen here. We have to take away water here. That is the reason. And the only reason is atom balancing is one of the biggest things that you can always say. Here, there is oxygen here, and there is no oxygen here. Why? That is why we have to introduce this single hydrogen. So whenever there is oxygen, just add hydrogen ion to it. And hydrogen plus oxygen obviously will form water. That's why we usually put water here. That's the only reason. That is the only reason. So you don't need to say, oh, Mr. Nkwocha, what did you do? Yeah, of course, that is exactly what I did. Because it is already in this ionic form. It is not a polyatomic radical. It is not a joint radical. So it's just a single. So this is a radical on its own. It's not like when we do K2SO4. Where I now do K2 plus SO4, 2 minus. So this is a joint radical. So the SO4 is a joint radical. That's why we can push all of them together away, just like that. But here, the radical together is now we are dealing with that radical all on its own. Okay, so it is the radical that we are dealing because it's for like KMNO4. Now we have successfully pushed this potassium because MnO4 is a radical on its own. So this is simply the reason why we do not throw the oxygen away because it's a radical. This is how we treat radicals. If you throw the oxygen away, you have spoiled the chemistry of that radical. So that is exactly what happened there. Sir, please, can I send some questions to you on chemical equilibrium? Of course. Send me questions on chemical equilibrium on the WhatsApp page, and I will always answer your questions. That's an easy peasy. So that's like one of the easiest topics that you always pass in the exam. But if we have time, we are going to do revision and then. Okay, so that is how we deal with. So this you can see. Look at this one now. This is another radical. You can see here. This is the same thing. MnO4 is again coming back here, and it's the same thing. So that means they're going to be adding that hydrogen goes with this guy, and water goes with this guy. So that means that is going to definitely be on its own. See, you can do this on your own. So the oxidizing agent, remember, is automatically because this guy has oxygen here. I'll just call it oxidizing agent because that's straightforward. You don't even need to think about it. But you use the number of electrons to determine which one is oxidizing agent and which one is a reducing agent. How do I do that? Just compare what I did here to look at what I did in the previous slide. So you have to calculate. Oh my God, I didn't really show this in properly. That's horrible. This is really, really horrible. I'm so sorry, guys. I'm supposed to do like first step, second step, third step. But if I'm explaining this in the first step is to calculate the oxidation state of manganese here, that manganese ion here, and compare it to this. Here, manganese is +2. Here it is +7. So you need to calculate it because you say MnO4 minus is equal to -1. So oxygen is Mn plus 4 in the bracket -2. This is -2 is equal to -1. So -1. So if I say Mn here is equal to +7. So that means that's why so it is +7 here now. It is +7 now. And now it's gone to +2. What is the difference between 7 and 2? It's 5. That's why I have this 5 electron here. What is the difference between Fe2? Is 1. But to balance it, make sure the number of electron loss is equal to the number of electron gain. I will have to multiply this whole equation by 5. And that's why everybody here has 5. Okay, so if you're writing WAEC, every equation every equation step you write, even calculating the oxidation step like this is 1 mark or 2 marks. So don't be afraid. If it is only how to calculate the oxidation number you know how to do it in WAEC question, do it. You will still get 1 mark or 2 or 3. So don't go and say, me or more, I will not leave it. I don't know it too. I will leave it. No, don't do that kind of thing. Doesn't make any sense. You must steal as many marks as possible. That is what WAEC expects you to do. Okay, so I think I've already solved these questions and the answers are there. I don't care about test for Z agent and reducing agent. That is what you should go and learn on your own. So, ladies and gentlemen, the application of this redox reaction is what you can always do. Oxidation, corrosion of metal is a redox reaction, combustion is a redox reaction, and that is photography development involves oxidation and reduction out of silver atoms. You can check out this concept. It is jam question. So when are we having another physics class? Okay. I will ask the physics teacher if he has time. So usually weekends he doesn't have time on Mondays and Tuesdays, on Fridays and Saturdays he doesn't have time. So, but Monday, Tuesday, Wednesday, I will ask him once he says he'll be available like Monday or Tuesday. I'll just put it on the WhatsApp group and notify everybody so that it can be part of the physics class. Okay. See, gentlemen and ladies, that's the end of oxidation and reduction. In bleach acts on stains by oxidizing them. See, that's very easy. Explosives for nitrogen, for neutral gases and nitrogen form compounds. So these are just things that you can easily use to remember. Other things, and that is the end of oxidation and reduction for you to play around. Okay, here we have entered electrolysis. I like this part. I deliberately send this PowerPoint to you guys so that you have opportunity to watch very interesting videos. I don't care about this video because you can watch it on your own. So, what is an ionic bond? Yeah, this is just for you guys to play around with. Um, in ionic compounds, there's usually an attraction between the metals and the non-metals, and that attraction forms an ionic bond. And then that bond is usually like the strongest bond that you guys will ever know. Oh my God, strongest? How come? So guess what happens? When you put this ionic compound inside the water, put water inside, you know what happens there? Water splits this compound. Wow. Well, how does that mean by splitting? Water helps the compound dissociate this, they actually split to their component ions. So once they split like that, boom, to make everything easy for us, we connect this container to an electrical circuit. And once you connect it to an electric circuit, the ions will be separated. Positive charge, you look for the positive to the negative terminal because unlike charges attract, while the negative charges will go to the positive terminal because unlike charges also attract. So positive charges goes to the negative terminal, negative charges goes to the positive terminal. And then what do you mean by positive terminal? Let's do a terminal. Let's just make a terminal. So this is the negative terminal and this is a positive terminal. So let's connect it by virtual electric cell. Let's just say, so that's exactly what about. So let's say we have sodium and chlorine here. So this is minus and this is plus. So the chlorine guys will go to this guy here. And the sodium guys will go to this guy here. And what do you think is happening here? Those positive and negative terminals are where electrons enter and leave the solution. So that means there are electrons there. Wow. Yes, there are electrons there. It is those electrons there that make everything happen. So think about it. Sodium is positively charged. It is electron deficient because chlorine has collected it. So if it is positive charge, it goes to this guy here and collects one electron. So sodium goes there, collects one electron, and becomes ordinary sodium ion. Can you see? The sodium ion is positive charge, goes to that negative terminal where there are electrons there and collects it. And then chlorine comes here and says, oh my gosh, there's too much electron. I have too much electrons there. And this positive terminal keeps giving away, keeps giving away, keeps giving away. Come on, let me give you one electron. So now chlorine goes here. Chlorine, I said, chlorine goes, chlorine ion goes and changes to chlorine and by giving away the electron. Wow. Yeah, that's exactly what happens. So at the end of the day, what does chlorine benefit? What is the benefit of doing that? So another chlorine right, ion goes away and does the same thing. And then they will see their brother. Oh my God, see my brother, you are here. Let us form a molecule. Ba-ba. Chlorine molecule is formed, Cl2. So this chlorine plus this chlorine leads to this chlorine. Do you see what is happening here? Yeah. So I am free at last. Chlorine has finally broken free from the connect from that bond between him and sodium. Why are we always forming salt? Come on, can't I just be on my own? I want a divorce. Okay, so gets a divorce and not the rest of them. That's the story for another day. You see, chlorine is finally set free. Sodium goes away. Oh no, I'm free. Sodium. Now I can react with oxygen when you expose me to air and burn. Exactly, that's what sodium goes. That's exactly what sodium does. Because sodium, remember your sister says sodium easily tarnishes in air. It just wants to tarnish, man. Come on, why am I always connected to this chlorine? I need to be free. I need to tarnish. It burns. That's what I mean by tarnish. So that's exactly what happens. It goes free. You see, the application here is that when you connect these ionic compounds. See, I'm taking back to SS1 now. Ionic compounds are those ones that conduct electricity. Can you see SS1 compound? Go and check the difference between electrovalent compounds and covalent compounds. Hey, so yes, so you see, ionic compounds are electrovalent compounds always um, does what? They conduct electricity. So that is why we are using them. And that's why I brought in this ionic bond. And that is how it happens. Do you know that this is the end of electrolysis? The rest is history. The rest is story for you. See, the rest is every other thing that we do in that electrolysis is secondary. This is just the beginning and the end. The question is, which one will preferentially decide? Which one, what is the quantity of electricity that was passed is secondary. You can do the calculation. Those ones are very, very easy. Okay, so now the chemistry of everything that's happening here, chlorine has migrated to the positive electrode. See, I brought in word now, electrode. And that positive electrode, I call it anode. What did he do at that positive electrode? Did he give away electron? Yes, that means there's an oxidation. If he gave away electron, that means oxidation occurs at the anode. Sodium went there and collected an extra electron. Reduction, can you see occurring at the cathode, which is the negative electrode? Mindset. All the chemistry is connected. Don't play with it. And then you see, it goes there, loses an electron, goes there, gains an electron. That's exactly what has happened. So in the exam, you see, in which of the following electrode does oxidation take place? Is that a question? Come on, you guys are smarter than that. So oxidation occurs at the anode, reduction occurs at the cathode. You cram. If you are the type of person that, oh man, that I have too many things to read, and then let me use the word. When Jesus Christ went on the cross, after after they nailed him on the cross, I think we just finished celebrating Easter. Sorry for my Muslim friends, I'm so sorry, but that's because I'm a Christian, so I have to use that analogy. So Jesus Christ goes to the cross, and they nailed him on the cross, and then like one of the scriptures showed that. No, let me not use that one. Okay, let me use it. When Jesus went to meet Lazarus at the cave, guess what he did? The shortest verse in the Bible, Jesus wept. So I don't want to be saying Jesus wept. So Jesus performed the electrolysis. ah, not ever. Jesus, I don't want to call it wept, so call it crow. Jesus crow. Don't say cry, don't say cry. They are trying to do chemistry. Jesus crow. So cathode is reduction. So C is cathode R reduction. A is anode, O is oxidation. Cathode is reduction, anode is oxidation. Beans, jam question. See, that's the one way to, if you are always looking for acronyms, remember, Jesus wept, don't say Jesus wept, Jesus crow, cathode is reduction. Yeah, that's how it works. So I'm just playing, letting you know that that's exactly what happened. That is what electrolysis is all about. Every other thing that we are talking about is easy. Will the compound conduct electricity or not? Copper, yes, but will it break down? No, because there's nothing to break. Sodium chloride, solid, will it break down? No, because there's no positive, there's no negative ions. Sodium chloride solution, will it break down? Yes, it will conduct electricity. Will this one conduct? Yes, because it's molten. Okay, so all these compounds conduct electricity only when they're in molten solutions. And this animation, this is supposed to be an animation, but I changed my laptop, so my animation doesn't work on this. It's not supported on this my current laptop. But so I can't play the animation for you, but that's okay. This is like everything I'm doing here is just beans. This slide alone tells you everything because this in WAEC they tell you the definition. JAM doesn't care about definition. Nobody asking this for JAM. JAM will say which of the following is the application of electrolysis? No, it's WAEC that will be asking you state three applications of electrolysis or state three importance of electrolysis. This is the answer. See the end from the beginning. Yeah, because this is why we do electrolysis to purify copper, to protect metals, to extract metals, to make compounds like chlorine, sodium. You see, sodium oxide, sodium hydroxide. These are like the applications of electrolysis. So, like basically, this note is self-explanatory. So please, can you say explain electrolysis even though it's simple? What's time? 7:16. Come on, have I not just explained it to you? I just did the simplest thing you can ever imagine. That when electricity is passed into a solution or a molten compound, the compound breaks. The positive ions goes to the negative electrode. The negative ions goes to the positive electrode. And that's where chemistry happens. Okay, so and then we talked about, did I like, oh, yeah, this is everything I've just been saying is on this side. Mechanism of electrolysis. See, is there. You can do that by yourself, but I'm going to show you the ones that are difficult for you. Strong electrolyte are those ones that will conduct a large amount of electricity. Weak electrolyte are those that are struggling to just conduct electricity. Non-electrolyte do not conduct it at all. They are mainly covalent compounds. So if you can remember covalent compounds that are covalent in nature, yeah, or organic compounds. Most organic compounds do not conduct electricity. But of course, some of them still do conduct electricity. Why? Because of hydrogen bonding in them. Yeah, ethanoic acid has hydroxylic group OH, so there's hydrogen bonding in there. But ethanol, the polarity is very, very high, so it doesn't conduct electricity. But wait, this is because it's secondary school. When we go to university, when you get to university, I can make this ethanol conducting. So somebody raises his hand, you can unmute yourself and ask a question. If let me hear your voice. I think my time is far, far spent. Now I just clocked 1 hour, okay, of this lesson. Um, do I need to stop or do I need to push on? So that is question for you guys to answer right now before I run away. So as I always do, I already have a topic thoughts. I've already taught this topic, so and it's on YouTube. So I think I don't know if I've uploaded it on YouTube, but these topics I've already taught them in the past, not like some other. No, like this is the fourth edition of this free chemistry lesson. So I've been doing this since 2020. Yeah, during the COVID year, I've been teaching this free chemistry. So like this is the fourth year. So I have some of the notes, some of the classes I've posted them on YouTube. If you want to go back and watch them, if you like my explanation, yeah, that's kind of encouraging. I've never asked you guys to subscribe, but you can always subscribe. Yeah, it's just subscribe, subscribe, subscribe. I imagine having one of that I had about seven views in one of the classes that I just taught recently. I'm like, wow, that was incredible because that means I did a simple, fantastic job. Okay, so I'm still waiting for you guys to decide, should we end it here? And I'll post the many videos. The data is running. You can completely watch the class on YouTube and let me know. The rest is just history. Or if I'm to use a preferential discharge, what is produced at the anode, what is produced at the cathode. The note is really, really self-explanatory. So you can stop. Thank you so much, man. I appreciate that. So because it's Saturday morning and it's afternoon in your own side, and we have a lot of things to do. So I really appreciate you guys for like turning up today, man. Today I enjoyed teaching this topic today. I hope you